everybody, very good evening and a warm welcome to Vedantu Enlite. This is your master teacher Nabamita Mam, and today we are here to discuss some of the most important questions of coordination compounds like I promised. Hannah, when I was teaching you coordination compounds, I told you that we will be doing some of the important questions because a coordination compound is such a chapter that you have to practice. If you don't practice, then everything just goes poof. It's just out of the mind completely, isn't it? And that's why it's very important that we practice. So today we are going to practice. There are something around 25-30 questions, so we will take a look at all of that. Yes, quickly go call up your friends, let them know that I am going live so that more students get benefited from this session. Yes, everybody, quickly go and call up your friends. Hello Kartik, hi Suresh, how are you? Very good evening and a warm welcome everyone. So shall we start? Shall we start, my dear students? Are you going to call up your friends or no? No? What do we do? Should we start or not? Come on. I don't see any chat. Hello. Hello Suchi. Hello. Quickly let your friends know, Baba. Why aren't you coming in the right time? This is for your exam practice only. You don't have to practice. Should I not take the class? Hi Balaji, Are back. Yes, hi Balaji. So happy to see you. Alright, I think let's begin here. Okay, let's begin here. By the way, let me tell you that this Children's Day in Vedantu, we are celebrating Online Child Safety Week. I don't know if you know it, but there is no other company who has been doing this, and child safety is something that is very important, that I believe. In fact, even for us, online safety is something that not many people know how to deal with it. Even when we are teaching here, there are times when somebody comes and abuses us or something, and these things are even more serious when it comes to your age, because you do not know how to deal with it. But because I would say that we are somewhat trained, we know how to deal with it, but even then sometimes when it happens, we are also taken aback. We're like, okay, what just happened? Why is someone abusing me like this, right? These kind of things happen. But when it comes to you, that's even more difficult. Okay, that's even more difficult. All right, everybody. Yes, are all the double salts are coordination compounds? Yes, Mahis, we can say that. Okay, we can say that the double salts are coordination compounds because they are complex, they are not simple salts. Okay, all right. So this Children's Day, this week we are going to celebrate what? We are going to celebrate Child Safety Week. All right. So everybody, I hope that somebody is telling me Vani ma'am took a session. Yes, so you must be knowing about it, isn't it? Now moving on from here, now that you are already here in Vedantu Enlite, don't forget to like this session. Don't forget to subscribe to the channel, because you know that this is the only official channel where every information regarding JEE and NEET is given to you only in English. No other language is followed here. So if you are someone who is looking for something in completely English, then this is the channel for you. So don't forget to like and share and subscribe to it. And you know my introduction. I am your master teacher Nabamita Mam. I teach you inorganic chemistry in this session. In this channel, and apart from that, I think that's all you need to know. So moving on, let's start with our first question. What do you all say? Everybody ready? Can I get some fire emojis or thumbs up or la? Just write down something and let me know that you all are ready, everybody. Come on. Just write down something and let me know that you all are ready. Come on. Also, if possible, do write down the questions. That will be easier for you. Okay. Hi Balaji. Hello. Okay, Suchi is ready. Tilagavati, hi, welcome. Long time. I didn't see you in the last classes. Yes, Hari Ramesh is also here. Amazing. People are giving me emojis. Okay, great. Now moving on. Let's begin, everybody. Okay, let's start. So here is our first question. The first question is, everybody. In fact, I have taught you this. I had while I was teaching you, I had told you this. Yes, this was there in the slide. Now tell me. The crystal field splitting energy for octahedral delta O and tetrahedral delta T complexes is related as what? Come on, can I see the answer? Tilagaviti, you are telling me option B. How did you find out? Did you just remember it, or how did you find out? Balaji, very good, very good. A lot of people are telling me option B, but how? How did you figure it out? Is it something that you have just memorized or did you understand the concept also? Tell me. You have just memorized or did you understand the concept? Sweet melodies was also, I taught you exactly. It was there in the slide, isn't it? It was there in the slide. Okay, very good everybody. Yes, the correct answer is, it is option B. Okay, delta T is equal to 4 by 9 delta O. Very good. Yes, octahedral field energy is greater. So let me just tell you this again. Okay, if we want to actually know, okay, if we actually want to know and understand this again, tell me the ratio of the number of ligands in tetrahedral field to that in octahedral field. What is it? It is going to be what? 4 by 6, right? Isn't it going to be 4 by 6? So 4 by 6 we can simplify it as 2 by 3. It is 2 by 3. And then moreover, it is also said that the splitting, okay, the splitting is reduced in tetrahedral by 2 by 3 again, okay. Yes, by 2 by 3 the splitting has been reduced in tetrahedral. So now that means that delta T will be equal to what? It will be equal to 2 by 3 into 2 by 3, because this is 2 by 3 into the splitting has been reduced by 2 by 3. So that will definitely give us 4 by 9, isn't it? So 4 by 9 octahedral. Yes, this is what we get. Do you understand this? Do you understand this? And plus it was actually there in the slide as well when I taught you coordination compounds. Okay. Alright. Chalo, moving on. Yes, it is 4 by 9. Do not forget it. Okay. Do not forget it. For square planar it is 1.3. Okay. For square planar it is 1.3. For this it is 4 by 9, and I think for delta for octahedral it is 2 by 3. Okay. Alright. Moving on everybody. Next question for you all is, tell me, the correct order of intensity of colors of the compound is what? Okay. Do you observe that all of them are nickel? Do you observe that all of them are nickel? So how are you going to find it out? How are you going to find it out? Now you have to figure out which one is the strong ligand. Which one is the strong ligand? If there is a strong ligand, then the strong ligand will be able to make the splitting more, right? The splitting will be more and the color will be definitely lighter the color will be of definitely lighter shade. So you tell me which one will be the correct answer. Go ahead, let me know. Very good. Some of you are actually giving me the correct answer. Let's see. Correct intensity. Okay, correct order of intensity. Tell me. C, you are saying, how did you say C? Gautam, why are you saying C? Let me see. Did you get the answer or not? Did you actually get the answer, or was it just like tipka? What was it? Cn is the strongest, you are saying. Okay. The correct answer is B. Cl is the strongest. Okay. This is the strongest. Okay. This is the strongest. Yes, you forgot. It is Cl, then it is H2O, and then it is Cn minus. Okay. Then it is Cn minus. So the correct order will be option 2. We all know that the complexes are nickel, right? As we all can see, all of them are nickel 2 plus. So the stronger ligand, greater is the splitting and lighter is the color. Okay. So order of strength of ligand will be Cl minus, then H2O, and then Cn. So it will be option B. Yes, Anu, line by line will also come, but first we will complete all of these, okay, because we know that exams are coming up. So first we will complete all the syllabus and then we will come back and do all the elaborates this thing also. Don't worry about it, okay. Moving on, next question. This has already come in AIEEE 2001, okay. So chances are something like this might come in your exam, but not exactly this question. Anyway, tell me, the complex ion which has no d electrons in the central metal atom is, and how are you going to solve it? Please tell me this. Yes. Yes. Tell me everybody. Tell me. We saw that, no, Balaji, what is written here? We saw that, right? I'm so sorry. Did I say it ulta? I think I said it ulta. Yeah. Sorry. As you can see that Cn minus is the stronger one, then comes H2 and then comes Cl. I said it the opposite. Sorry. I'm so sorry. I said it the opposite. I said that Cl is stronger and then I said that Cl. Sorry. My bad. Yes. That was absolutely a slip of tongue. Yes. Cn is stronger, then comes H2, then comes Cl. Okay, so this is the correct answer. That's exactly how it is written. See, that's exactly how it is written, because Cl is weaker, so the color will be seen more here. Okay, the color will be seen more here. Thank you so much, Balaji. Thank you so much. Yeah. Now tell me what is the answer. Hari Ramesh, how did you solve it? Tell me how did you solve it? Then only I will be able to understand if you have actually solved it or not. Come on. Go ahead, let me know. The complex ion which has no d electrons in the central atom, central metal atom is, what is it? You tell me. How will we figure it out? Do you remember how I taught you that you have to find the oxidation state? You have to find the oxidation state. Do you remember, Balaji? How did you tell me that? Tell me, what is the oxidation state? First we find out the oxidation state. So to find out the oxidation state, do you remember I told you that the central metal atom, it will be written as X, right? And then what is the complete charge here? The complete charge, let's write it as -1 because it's -1 minus, we can see. And then we know that oxygen has -2 charges, right? Oxygen has 2 negative, right? Yes. So 2 negative into 4, what will it be? It will be -8 here, correct? So that means if I solve it, so it will be X is equal to -1 plus 8, which means it will be 7. So Mn is in +7 oxidation state, right? Now what is the atomic number of manganese? 25. 25 is the atomic number. If it is 25, then what will it be? Its electronic configuration? It will have 3d5 4s2. Now it is +7, right? So okay, let's take a look at it. Manganese has atomic number 25 and electronic configuration, the outermost shell will have 3d5 4s2, right? Now it is +7, that means all of them are gone. Yes, all of them are gone, so it will be 3d0 4s0. So that means we can say that, of course, this complex will not have d electrons. Am I right? This complex will not have any d electrons. So obviously option A is the correct answer. So if any of these kind of question comes, then please remember that you have to calculate the oxidation state. Okay, you have to calculate the oxidation state. There are some more questions also. Let's take a look at that. Chalo, moving on now. Okay, this we understood. Now, which of the following is the limitation of valence bond theory? Look at this. Tell me. And tell me, which of the following is the limitation of valence bond theory? It does not distinguish between weak and strong ligands. It does not give quantitative interpretation of magnetic data. It does not explain the color exhibited by coordination compound, or is it option D, all of these? You tell me. Hari and Balaji, very good, absolutely right. The option is all of this, because we know that yes, it does not distinguish between weak and strong ligand. We did not speak about weak and strong ligands when we were talking about valence bond theory. The weak and strong ligands only came into picture when we were studying about crystal field theory, right? We only spoke about weak and strong ligands during crystal field theory. Exactly. It does not give quantitative interpretation of magnetic data. Did we even speak about Bohr magneton or magnetism, diamagnetic, paramagnetic when we were learning about valence bond theory? Not at all. Yes. So that means that was also not there. And of course, it does not give the color. It does not also explain the color exhibited by coordination compound. So it failed in all of these things, and that's why crystal field theory came into picture. Okay, moving on everybody. Both NiCO4 and NiCN4 2- are diamagnetic. The hybridization of nickel in this complexes respectively are. What is the answer for this? What is the answer for this? Don't Google it out. Try to solve it, everyone. Please try to solve it and then tell me, okay? Don't just Google it out. How did you find out, Singham? How did you solve it? How did you solve it? Tell me, how did you solve it? Hi Vetri Kumaran, how are you? Welcome to the class. Come on. Arun is telling me D. How is it D? Arun, you also have to explain me the answer, bacha. You can't just click on the answer and tell me that yeah, this is the answer. Bad buddy, how? How are you telling me that this is the answer? Tell me. How did you figure it out? Strong field means, very good, absolutely right. The trick is, if it is a strong field, then what will it do? It will pair up, right? It will try to pair it up. And when it pairs up, there will be 1d orbital that will be either 1d orbital or 2d orbital maybe, but mostly 1d orbital will definitely be empty. And that is why we understand that for NiCN4 it will be dsp2. Yes, and for NiCO4 it will be sp3. So option B is the correct answer. Very good. Okay, option B is the correct answer. It is sp3 and D sp2 is the correct answer. Got it? But otherwise, if you have to find it the long way, then what you will have to do is you will have to find the oxidation state of both of them, then find the d orbital, then you know which one is what ligand. If this is weak ligand, if this is strong ligand, then you find out which one will pair it up, which one will not pair it up, and then finally you get the answer. But otherwise, the trick is that if it is a strong ligand, it will definitely try to pair it up, and then one d orbital will be empty. Okay, so that's the way to solve it. Chalo, moving on everyone. Now, the spin only magnetic value in Bohr magneton units of CrCO6 is, tell me. CrCO6. Tell me guys. The spin only magnetic moment value in Bohr magneton units of CrCO6 is. Who is going to give me this answer? Zero. Now how did you figure this out? How did you figure this out? Carbon monoxide has what? D, 5.92. Really? That's not possible. The answer is 0. That you are right. Absolutely right. Yes. Now, carbon monoxide being a strong ligand, this will also make pairing happen. And if pairing happens, then obviously magnetic property comes from unpaired electrons, isn't it? From unpaired electrons. But here, there will be no magnetic there will be no magnetic moment, as all the electrons will be getting paired up, right? So if it gets paired up, then there will be nothing. So 0 is the answer. Yes, option A is the correct answer. Very good. Well done. Moving on. Next question. The complex showing a spin only magnetic moment of 2.82 bm is. Okay, let's figure this out. Yes, Nandini, that too. Absolutely right. That too. Figure it out here. Tell me what's the answer. C, no Singham. C is not possible, yeah. C is not possible. C is not at all possible. Come on. Are you sure? Orchid, okay. I can see different answers. I'm not very sure. Which one is the correct answer? Someone is telling B, someone is telling A, someone is telling C. C is definitely not the answer. Something will have to be happen. No, something will have to be the answer, right? A or B or C or D. That's it. You have only correct. Suchi, that is absolutely right. Yes, that is absolutely right. But all of them are weak ligands. Huh? All of them are weak ligands. Are you sure about it? All of them are weak ligands. Vetri, you are saying 2 unpaired electrons. Yes. So that means Cn is strong. Okay. Then D. Someone is telling me D. Okay guys, let's do this. Okay. Now CO. Yes. This is also a strong ligand. Okay. This is also a strong ligand. Alright. This is also a strong ligand. Anyway, moving on. Let's talk about it. The correct answer, my dear student, is option B. This is the correct answer. Option B is the correct answer. Okay. Option B will be the correct answer, because we know that for this is 0, this is 0. If we find the oxidation state, then we will find out that these two are not possible. But this, and out of this also we know that this will be the correct answer. Okay. This will be the correct answer. Very good. Absolutely right. Yes. Moving on. Now, the IUPAC name. Okay. This is something that we all have to practice a lot. So tell me, what is the IUPAC name of K2PtCl6 is? Remember the rules now. Now you will have to remember the rules. Tell me. Now you will have to remember the rules. Which one do you write first? Positive or the negative? Positive or the negative? Are you sure? Are you sure? Option B. You write the cation first and then you write the anion. Yes, cation first, anion next. Yes, absolutely right. Okay, now then B is confirmed, huh? B is confirmed. I'm actually very happy. So there were 4. See, there are a lot of other things also that you could deduce. Okay, this is definitely wrong because potassium is the positive ion. Potassium is cation. Yes, PtCl6 minus, it will be anion. So obviously you will write that later. First you will write the cation. Okay, that's the rule. Now secondly, we also know that if it is negative ion, then anion always ends with 8, ATE, isn't it? So platinate will definitely be there. You also have to write the oxidation state which is there, that is not here. So that will be wrong. Yes, and here they have written platinum, so this is also wrong. Option B is the only correct answer. You know what? Clap for yourself, everybody. Clap for yourself. Absolutely right, Singham. Yes. So what are the things that we have to remember? We have to remember that it must have first cation, second anion. Then you write the anion. If the anion, obviously anion always ends in negative charge. If it is anion, then you are going to write ATE, right? You are going to write ATE, alright? And then you also have to write mention the oxidation state of the central metal atom. So all of these are important. These rules, if you know, you will be able to ace the IUPAC name, okay? Alright, thank you, Vetri. Thank you so much. Now, AIEEE 1993. Oh, this was the year when I was born. Anyway, among the following ions, which one has the highest paramagnetism? Tell me. For this, what do you have to do? For this, what do you have to do? Calculate the oxidation state. Calculate the, what all of them are, yes, calculate the number of unpaired electrons. The highest number of unpaired electron will have the highest paramagnetism. So everybody find out on your notebook, find out which one has the highest unpaired electrons. Everybody go ahead. You all know how to find out the highest unpaired electrons also, right? Come on. Singham, are you sure? Aditya, you are right. Balaji, think again. Royal, you are right. Did you all actually find out the oxidation state and the number of unpaired electron? Yes, absolutely right. Charan, please check out Shreyas sir's video. Shreyas sir has recently taken a video and he has told you about all the major details and information. Please check that out. Yeah, please check that out. Very good. Very good. Option B is the correct answer. Why? Because iron has maximum, that is 4 unpaired electrons. Yes, and that is why it will show the highest paramagnetism. Okay, it will show the highest paramagnetism. H2O is a weak ligand, so it will not be able to pair up the electrons. So there will be more of what? Unpaired electrons, and that is why we will be writing that this will have the highest paramagnetism. Okay, all right. Yes, very good. Moving on, can't we just say? You can, but I just think that this is easier. Okay, to find the oxidation state, to find the number of unpaired electrons, it is easier, and this will give you a short answer. So that makes more sense. Okay, but you can do it in both the ways. You can do it in both the ways. Whatever seems easier to you, whatever seems like you can do it in a snap and you can get the answer, do that, because obviously in competitive exams like NEET or JEE, time matters the most. Okay, time is the biggest factor here. Okay. Alright, anyway, what is the IUPAC nomenclature, the name of the complex? Please tell me, go ahead, let me know. Who is writing? Option C. Okay, why is it option C? Think again. Take a look at all of them. There are minute differences, okay, minute differences. I'm not going to tell you which is the correct answer. Please look at it again. You will be able to figure it out. It's very easy. You all know the answer. It's very easy. Alphabetical order, spelling. Check out the spelling also, please. Very good, Aditya. Give it up for Aditya, everybody. Please clap for Aditya. Aditya has pointed it out correctly. Yes. Option D is the correct answer because as you see, diamine, okay, A-double-M, alright, A-double-M, diamine, tetra, aqua, see, tetra, aqua, both the A will come, okay? So tetra aqua cobalt 3 chloride. That's what is the name. Very good. Very, very, very good, okay? Option D is the correct answer. Moving on. Which of the following complexes are homoleptic? Do you know what is homoleptic? Homoleptic basically means all of them are same. This is again very easy. Manas, I'm not teaching class 6. I'm teaching class 11th and 12th, bacha. Yes, not teaching class 6 here, please. Yeah. I do teach class 6th as well. I teach 7th also. I teach 8 also. I teach 9 also, 10 also. And now I'm teaching 11th and 12th also. Please focus up here, okay? Yeah. Which of the following complexes are homoleptic? Tell me. Shinchan in Tamil. Jayashri. Okay. Many students are saying only one thing. Good. Very good, I guess. Very good. Yes, it is option 1 and 3 because we see that all of them are same, isn't it? All of them are same. Very good. It has to be option D. Okay. 1 and 3. Homoleptic complexes are compounds in which the coordination compounds in which all the ligand which are connected with central atom are either same or identical. Okay. It has to be same or identical. And in this case we see that these two are the identical. These two has what? Identical and same atom, same ligands, right? So that is why this will be the correct answer. Moving on, next question. I think this is the last question. I think we are done already. Yeah, we're pretty much done. Nice. The oxidation state of Cr in CrH2O6, Cl3, CrC6H62 and okay, so this is such a huge name. I don't feel like reading it, but okay, I'll read it. K2Cr, NH3 respectively are. Tell me. Manas, I do teach class 10th, but you will have to come to my AI classes, okay? I teach class 10th in AI live classes. So you can buy that AI live course and you can come to my class, okay? Yeah. Tell me. Balaji, you found out already. Huh, you guys are super amazing. Very nice. Okay, Netaji is telling me a different answer. Lakshman is telling me a homoleptic complexes, hidden signs you did not see. Wait, I'll show you what is homoleptic in some time. I'll show you what is it. I'll show you the definition. Don't worry. Let's do this first. Very good. Everybody knows it. Well done. This is how we will calculate it. See, what do? We always take the metal to be as X and then we find out the charges, we add them and then we equate it with the whole charge. Whatever is written here, with that we will equate it, okay? And then we will find the oxidation state. Am I clear? Yes, in this when we find out for all of them, we see that it is +3, it is 0 and it is +6, okay? With this note, this was the last question for today. We are done with the important questions. That's very good, everybody. But now coming back to the hidden signs, you asked me what is homoleptic complexes. Here, bacha, take a look at it. Homoleptic complexes are compounds are those coordination compounds in which all the ligands which are connected to the central atom are all same or similar or identical. Got it? That's the answer about homoleptic compounds. Okay. So with this note, everybody, we are done with today's session. I hope that you all understood the questions that I have done here. Okay. And please do more and more practice questions. In fact, I will give you more practice questions and like I said that I have spoken to the channel manager already and I have please do sessions in the morning. But morning may I have some more classes? No. Morning may I have some more classes. Vimal, what is bident ligand? You haven't watched the previous sessions. I have already taught the coordination compound sessions, bacha. Can you please go back and take a look at it? Yes. I'll do that also. Jeshri, you know what? I'll give you the notes. I'll write it down. What are the strong ligands? What are the weak, weak ligands? I'll write all of that down and I'll give you. What is the weightage of this chapter in JEE? The hidden signs, I have just put up a video. Please watch that. Yesterday only it has come. The weightage of inorganic chemistry. Watch that to find out what is the weightage of the whole inorganic chemistry and what are the chapters that you have to study more. Okay. So please watch that, everybody. Yes, coordination compound is already done. Coordination compound was the second chapter that I did in this session. Okay. It was the second chapter that I did in this channel. Alright. That was when I just had, come here. I have taken this. So please make a note of it and watch those videos that I have taken because I have actually completed almost everything. But then again, we will come back and we will do it elaborately as well. Okay. Alright. Mohammed Naseem, is it enough to solve Tattva for organic? See, organic or the whole chemistry, I would say. Tattva is a great book, no doubt. But with that, with Tattva, also solve previous year questions, no? Because previous year questions will give you a clear idea about what kind of questions come, or they will probably change the data, but mostly the questions look very similar. So please solve previous year question as well as Tattva, and then it is enough, then it is absolutely enough. Okay, all right, please tell how to approach organic chemistry. Organic chemistry you'll have to ask Wasim sir. Okay, that you will have to ask Wasim sir. Okay, all right everybody, with this note everyone, thank you so much. I had an amazing time with you all, hope you all did too. Don't forget to share it with your friends as well if they also want to learn. Okay, so tara, bye bye, have a nice weekend. I'll see you tomorrow. Tomorrow I'm coming with DNF block. Okay, so tomorrow I'm coming with DNF block. Be there 5 p.m. 5 p.m. tomorrow with DNF block. I expect to see you all, and I expect to see more students, so please do tell your friends as well. Okay, 5 p.m. tomorrow, DNF block. Okay, see ya, adios amigos, see ya.